Entonces vamos a iniciar. Quiero presentarles al doctor Tom O'Brien. El doctor Tom O'Brien es un especialista en medicina funcional. Es realmente una persona muy reconocida a nivel mundial. Él ha sido conferencista a nivel internacional. Es el autor de estos dos maravillosos libros que para los que no los conocen, los pueden encontrar ¿verdad? En los diferentes lugares donde venden libros, pero este particularmente está en español y lo pueden conseguir acá en Costa Rica. Pero el doctor O'Brien es un experto en todo lo que es el tema del gluten, es un experto también en enfermedades autoinmunes y pues él ha sido conferencista internacional y lo sigue siendo, trabaja en muchos workshops. Él es el día de hoy nos va a estar hablando de algo que él conoce muy bien, que es esa relación del intestino con el sistema inmune y la importancia que tiene tener una buena salud intestinal en este momento que estamos pasando por esta pandemia. Así que muchas gracias and welcome, Tom, and thank you for being here. This is our 4 or 5 webinar. Yes, it's 5 webinars. I was remembering that the first time that we had our webinar, it was very, wow, incredible. And also I was telling Javier, my husband, that it's always like the first time is the same emotions, the same feelings. So thank you, really.
Thank you. Thank you so much. Thank you. It's hello everyone. It's a pleasure to be here. I very much enjoy these webinars with Dr. Patricia and answering your questions. It is our goal for Dr. Patricia and I to bring functional medicine not only to Costa Rica, but to Latin America, Central America, South America, to bring the information of functional medicine to all of the healthcare practitioners who have an interest. So these webinars are the beginning of the entire project of what we are involved in to bring functional medicine to you. I'm going to share my screen now and get started with the presentation. Please feel free to put your questions in the Q&A and we will answer every question that we can. So this seminar this evening is on the connection between the intestines and the immune system. And my thought is to talk about just a couple of aspects of it to begin this conversation, that we will have more seminars on this topic because it's critically important to, of course, support the immune system, but to support the immune system, including the immune system of the intestines. So we will have a number of seminars on this topic, not just tonight. This will be the beginning of more seminars on this topic. So I want to remind everyone that we have done 4 of these webinars already. The first one last year was in April of 2020 on boosting the immune system in times of this viral infection. All of that information is still relevant today, and we will give you the links so that you can go back to watch any of these webinars that you would like. The next one we did was on gluten. And for those who have not had a chance to see this webinar, you will understand why gluten is a problem for so many people when you have a chance to watch this seminar. The next one was on intestinal permeability, the leaky gut. And we had many videos and pictures and explanations that as you understand what we talk about in this webinar, nobody can question your knowledge about intestinal permeability. You will understand how it impacts on the development of inflammatory diseases, all inflammatory diseases. And then the last one we did was on autoimmunity. Where does it come from? How does it develop? What are the tests that you can use to reduce your risk of autoimmunity or identify if you already are on the autoimmune spectrum? And in these webinars, we talked a lot, especially in numbers 3 and 4, about building the immune system in the gut. We talked about some of the foods, the diet, the vitamins that you can use to help strengthen the immunity of your gut. And I would recommend that to add on to what you learned tonight, you go back and watch these and take notes of what foods to eat, what vitamins will help so that you have a complete picture. And we have a gift for you that all of the studies I'm going to talk about tonight, the 32 studies that I'm going to talk about, they're all available to you. 29 of the 32 studies are the full articles. If they were free to me, they are free to you. I cannot give you articles that are not free to the public, but we will give you the link for the abstract of the articles. So all 32 studies are available. Just go to the dr.com/CR for Costa Rica, CR621 for June of 21. So the dr.com/CR621. They're all waiting for you there. So you can learn more about these topics after we are done here tonight. And I will give you that URL again at the end of the talk. So when we talk about current health status, it's good to remember. Now, this is my friend Mark Hyman, and this is a very good book to read for your patients to understand how do foods relate to different diseases, and how do I get a handle on what foods are good for me and which foods are not. It's a very good book. It came out last year. And what Mark tells us, only 12% of Americans are healthy in terms of how their metabolism is working. 1 in 2 Americans have diabetes or pre-diabetes. 1 in 3 have non-alcoholic fatty liver disease. 75% of Americans are overweight. 42% of Americans are obese. And in New York City, about 40% of the hospitalizations right now are people between the ages of 20 and 40. This is true in all of the developing countries. The statistics may be a little bit different, but this dynamic is occurring everywhere. Well, in Costa Rica, the impact of diabetes in Costa Rica is that it's projected to double within 13 years. It's going to double. This article came out just a few months ago, and that diabetes is going to double, but it's already bad in Costa Rica. That if you look at the prevalence of diabetes, and Costa Rica is on the top here, and after that's the United States, and you can see they're neck and neck. The dark bar is the total, the light blue is for male, and the gray is female. And you can see that Costa Rica, United States, Mexico, Barbados, they're very similar in the percentages of people that have diabetes right now. And what I want to point out to you is that this came out just last year. So what's happening in the United States is happening in Costa Rica and in all of Latin America. The prevalence of being overweight for children in Costa Rica, 34%. And children aged 7 to 9, boys, children from urban areas, children of a higher socioeconomic status, were more likely to be overweight. And the prevalence of obesity was 26%. 1 out of 4 children are obese. Now, what I want to show you about this study is that this study was done almost 20 years ago, and the numbers are much worse now. That the healthcare system is not successfully changing the direction of our children's health. That more children have obesity and more children are overweight now than ever before. You can see how the numbers are just increasing for obesity in Costa Rica. And this is, why are we talking about this? Because obesity causes the inflammation. It activates the immune system, which then produces the inflammation that's 24/7, all day, every day. Your immune system is producing these inflammatory cytokines because of how much extra fat people are carrying. And it's very difficult to have a protective immune system when it's working constantly trying to protect you from yourself. It's trying to protect you from the toxins that are in the fat cells. And that's a primary reason why you're producing so many inflammatory cytokines, is because you don't get more fat cells after the age of 2 or 3. They just get bigger and they get filled up and they get bigger and bigger. And what are they getting filled up with? More and more toxins. And your immune system is producing these inflammatory cytokines to try to deal with all the toxins that the body is accumulating. Very, very difficult dynamic to deal with and maintain a healthy immune system. The number of obese ticos has quadrupled in the last 4 decades. Quadrupled, 4 times higher now in the last 4 decades. And the malnutrition in the Global Nutrition Report, Costa Rica is way off course in trying to meet the global nutrition targets. Too many people are overweight. Too many people are obese. And the rate of obesity and overweight is going up. It's not going down. And the rate of diabetes is going up. It's not going down. And when we look at the report card for Costa Rica from the Global Nutrition Report, what we see is that female obesity, there's no progress and it's getting worse. Male obesity, no progress, getting worse. Female diabetes, no progress, getting worse. Male diabetes, no progress, getting worse, which means that we have to change the way we think about this. And we have to educate our people on selecting the proper types of foods to calm down the immune system. We will talk about this tonight. So the Italians came up with a topic, they called it inflammaging, meaning the overexpression of your genes of inflammation that turn on the immune system and genes associated with the lysosomal system. When you have more inflammation, you age faster. And as we are aging faster, we're causing more tissue damage, developing more instability in our blood sugar, more pre-diabetes and diabetes. What was basically set up as our defense system, the immune system, can be a cause of disease and turns out to be the primary pathway of chronic disease. Now, what I want you to remember is that there is so much inflammation, but it's not an exaggerated amount of inflammation. It's not an exaggeration. It's an overexpression, meaning your immune system is having to be active. It's having to speak all of the time to try and protect you. What's it trying to protect you from? All of the toxic crud that we're being exposed to in our environment today. Your immune system is there to protect you. It's the Army, the Navy, the Air Force, the Marines. The immune system is just there to protect you. And when it gets activated, it's not exaggerating. It's activated for a reason. It's trying to protect you. That's a very important concept that we need to understand. So is it immune dysfunction, or is it an immune system doing exactly what it was set up to do? I propose to you, it's not an immune system dysfunction. You don't want to shut down the immune system because it's not functioning properly. Rather, you want to reduce the need for the immune system to be so active. And we talk about that a great deal in the webinar on autoimmunity, the last one we did just prior to this one. So please go back and listen to all of the studies in that presentation about how the immune system is activated trying to protect you. It's not an over exaggeration. You don't want to shut down the immune system when you have an immune-based disease like an autoimmune disease. Rather, you want to work on symptomatic relief in the short term, but you want to eliminate the need for the immune system to be so active. That means identifying the inflammatory foods, identifying the inflammatory environment that someone might be in, mold, identifying stressful emotional toxicity. People may have bad relationships causing emotional stress hormones, which are very toxic and cause more weight gain, more inflammation also. That you have to identify where are the sources of the need for your immune system to be so activated coming from. We know that common factors that include inflammaging include obesity, the Western diet, intestinal permeability, the leaky gut, the loss of the diversity of the microbiome, when your body can no longer handle sugar very well and insulin doesn't work so good anymore, and you develop insulin resistance. And then when you have increased markers of inflammation like CRP, homocysteine, IL-6, things like that. Those are all factors that will increase inflammation more. Now, this was a patient who came in who was 25 pounds overweight, extremely tired, been dealing with chronic fatigue for a number of years, but really wanted to turn her life around, was willing to do what it takes. So she was put on a gluten-free, dairy-free, sugar-free diet, focusing on the colors of the rainbow in the foods that she eats, meaning many different colors, all day, every meal, especially breakfast, multiple colors of vegetables in her foods every day. An effort to rebuild the microbiome. We talk all about that in the webinar number 3, intestinal permeability. We talk about rebuilding the microbiome. She was given some nutrients for reducing the inflammation in her intestines, curcumin, vitamin D, and I have a gluten sensitivity pack. It's one pack that has 6 pills in it, and there are 22 nutrients in there. And she took the 1 pack a day of those. And she had a high yeast concentration in a stool analysis, so we did an anti-yeast protocol. 8 months she was very vigilant in following the recommendations, and this is the same person. No longer having chronic fatigue, no longer carrying the extra weight, and she said that a new lease on life. And I just wanted to show you the dramatic difference that is fairly quick. You know, things don't turn around in a week. People start feeling better within a month, but it's going to take 6 months to a year to turn around when people have long-term chronic accumulative inflammatory processes going on, like carrying an extra 25 pounds, having chronic fatigue, having chronic yeast infections. That takes a while to turn around. So why is the gut the central command center for our immune system? We all know that over 70% of the immune system is in your gut. That is the where the first line of defense is, from the mouth all the way down in the digestive tract. That is where the immune system is most concentrated. And people ask why? Why is that the case? You have the exact same body as your ancestor thousands of years ago. The same kidneys, the same gallbladder, the same liver, the same bones, muscles, joints, the same immune system. Everything works the same. So for our ancestors 5,000 years ago, what did the immune system have to protect them from? Bugs, parasites, viruses, mold, fungus, and bacteria. That was it. There was no bisphenol A, BPA, red dye number 42, processed sugars or artificial sweeteners, the gums that are put in so many different foods. There was none of that. Bugs, parasites, viruses, mold, fungus, bacteria. And in webinar number 2 that we did talking about gluten, you will recall that gluten is misinterpreted by the immune system as a harmful component of a bug, which is why every human develops intestinal permeability and inflammation in their intestines when they eat wheat. This happens to every human who consumes wheat, because your immune system thinks that wheat looks like the outside of a bug. The protein structure of gluten looks like the protein structure of the surface of bacteria. And so your immune system mistakenly thinks that it's fighting a bug. So every time you eat wheat, you get leaky gut. Every time you eat wheat, you get increase in NF-kappa B, the major amplifier of inflammation, every time, whether you feel it or not. That is why 70% of the immune system is in the gut, because our ancestors, where did they get bugs, parasites, viruses, mold, fungus, or bacteria? It was in the food that they were eating, because they're foraging for food. They're looking for food wherever they can. And when they find something, first they sniff it, and then they taste it a little bit, and then they eat it. And if there's bad bugs in there, the immune system has to protect them from that. That was the primary danger for our ancestors living on planet Earth in terms of what the immune system has to protect them from. And we have the exact same immune system as our ancestors. The immune system has the important function of protecting organisms from pathogens, from bugs. It should be able to identify a wide variety of agents, from parasitic worms to viruses, and at the same time distinguish your own healthy tissue from a parasite or a bug. Despite the fact that autoinflammatory diseases, meaning when your immune system automatically gets turned on to protect you, and it produces the innate cytokines, IL-1 beta, IL-6, tumor necrosis factor, interferon gamma, it produces these automatically to protect you. And that part of the immune system is very, very old. It's been around for as long as there have been animals, and turns out first appeared in jawed vertebrates. So even sharks have an innate immune system, but it's very ancient, the innate immune system to protect you. And it works automatically. It's going to always protect you if it thinks you're being exposed to a bug, parasite, virus, mold, fungus, or bacteria. That's what it's designed for. So it's going to treat any threat as if it's a bug, parasite, virus, mold, fungus, or bacteria. And I just threw this in here, an image of a cytokine storm, that when your immune system is constantly fighting, because of what you're being exposed to, either in the foods that you're eating. And as you know, every chronic degenerative disease is a disease of inflammation, which means there's a cytokine storm going in every chronic inflammatory disease. Now you get exposed to a virus and it can take you over the edge. And now you get what we fear of a cytokine storm in your lungs. And that is a life-threatening situation. This drawing was done in 2012, long before any concerns about a pandemic viral infection were around. And the cytokine storm that they're talking about here is the inflammation that's in the body all the time. It's a storm. When you are fighting and you eventually develop an autoimmune disease, you've got a cytokine storm going on all the time. Or if you have chronic fatigue, or if you have cognitive problems, there's a cytokine storm going all the time. There's inflammation going on all the time. And we tend to not pay attention to it. We look for the gross indicators of inflammation, like HSCRP or homocysteine or IL-6. And those markers have to be very activated for them to show up on a blood test. If you did a full cytokine panel, you would see the more subtle increases in inflammation throughout the body, So who are the first responders of immune function in the gut? What I wanted to talk about tonight are the first responders. I'm going to give you two examples of first responders of immune function in your gut. The first one is secretory IgA. And secretory IgA is the major mucosal antibody and the most abundant isotype in humans. It's secreted into the intestinal lumen at several grams per day. Secretory IgA acts both to prevent infections and maintain homeostasis of the good bacteria. And the first point of contact between the microbiota and gastrointestinal antibodies occurs in the oral cavity. It's secretory IgA and IgG. They're in the saliva, and the salivary antibodies robustly coat the oral microbiota. You may know that we have over 800 species of bacteria in our mouth. And secretory IgA is the primary protective agent from any pathogenic bacteria we have in our mouths. It will grab that bacteria, lock it up, and then escort it all the way through the digestive tract to be eliminated in the stool. It won't let go. Secretory IgA is our best friend and the first responder to any pathogens that we're exposed to. An even greater portion of the microbiota is coated with secretory IgA in the mouth and in the gut, with estimates of 70–80% of IgA bound to bacteria and 90% of IgG bound to bacteria in the saliva and the oral biofilms. It's the predominant immunoglobulin class in human external secretions. It's a key element in the maintenance of gut microbiota homeostasis, keeping balance for the bacteria in your gut. You must have this first responder of the immune system to grab the bad bacteria so that it can't compete in your intestines with the probiotics that are supposed to be there to protect you. Secretory IgA antibodies have various critical functions: immune protection against infectious agents, establishment of a healthy microbiome, and regulating the host and commensal homeostasis are the most important. It's got a big job. And I'm talking about this because when you do stool analysis on your patients, you will find that somewhere between 2 and 4 out of 10 people that have some type of a health concern, and so you're doing a stool analysis, somewhere between 2 to 4 out of 10 of them, that's 20 to 40% of your patients that you're recommending a stool analysis for, have a deficiency of secretory IgA. They have a deficiency of this first responder that is supposed to take care of you. It's important in protecting the respiratory and the gut mucosa against viruses. SARS-CoV-2 infects both areas. And if we don't have enough secretory IgA, and it can't bind to the virus when you're exposed to it, the virus then has an opportunity to set up shop, to shed, both in the respiratory system and in the GI tract, which is why that's where you get symptoms, if you get symptoms of SARS-CoV-2. So secretory IgA is the first responder whose job it is to grab that virus and don't let it go so that it just gets escorted out in the stool. The production of secretory IgA at the mucosal surfaces decreases with age and can lead to an increased risk of infections. This is one reason why our elderly are having more problems with this current viral threat that we have, is that the incidence of secretory IgA insufficiencies and deficiencies is much higher in the elderly. Viral, respiratory, and GI infections are a predominant cause of morbidity and mortality in the elderly, whose aging immune system contributes significantly to poor outcomes. As their immune system ages, you lose secretory IgA. The age-dependent modifications of the composition of the gut microbiota contribute to the defective local and systemic immune defenses in the elderly. Meaning, when the elderly have systemic immune problems like autoimmune diseases or cytokine storms, that it's been building up for quite a period. It's age dependent. As they age, their immune system's getting weaker and weaker and weaker, and they're more vulnerable to developing systemic immune responses. There is a family of bacteria called Bacillus that has been shown to produce antimicrobial substances, of course, to enhance epithelial gut barrier function, and it stimulates the production of secretory IgA in humans. Bacillus subtilis probiotic displays immunostimulatory properties and antagonizes GI pathogen infections by producing antimicrobial substances like secretory IgA. Consumption of Bacillus subtilis significantly increased fecal and salivary secretory IgA concentrations. How significantly? Well, for secretory IgA, a 25% increase when they took Bacillus subtilis probiotic for 10 days. I believe it was 10 days they took it. And in the stool, secretory IgA, 65% increase with 10 days of taking the probiotic, and 18 days after they were done taking the probiotic, they had an 87% increase, which meant that secretory IgA keeps going higher even after you're done going through the therapy of taking Bacillus subtilis. My recommendation is that patients take 2 bottles of this product, then just pause and let's see how your body does. That may be enough to resupply your body with the tools to make more secretory IgA, which is your primary protection from any bugs, bacteria, viruses, mold, fungus that you're exposed to. 10 days of probiotic, that's the bacillus intake, were sufficient to increase stool IgA 65% in treated seniors. An increased level of 87% was maintained 18 days after they were done with the probiotics. That's really great to see. And this is the product that I recommend. I really like the use of spores, and Megaspore Biotic is Bacillus subtilis. It's the spores. The reason I like using the spores so much is that a number of studies now have shown that when you take the spores, you increase other keystone bacteria, really important bacteria in your gut, like Akkermansia and Fecalbacterium and Bifidobacterium. They go up along with Bacillus and with secretory IgA. These other probiotics that are very important to produce your short-chain fatty acids, butyrate, acetate, propionate, these bacteria that produce those beneficial short-chain fatty acids. Did you know that butyrate is necessary, or butyric acid, same thing? It's necessary to heal breach of the blood-brain barrier, leaky brain. Whenever you're positive for leaky gut, you likely also have leaky brain, but that heals by butyric acid or butyrate. And so you want to increase these keystone bacteria that will produce more butyrate, right? So that's why I like the spores, that they have a number of trickle-down effects, benefits that they have. It's been shown in mice that 50% increased production of intestinal secretory IgA to a bacterial toxin significantly increased the vaccine-induced protection directly against that bug, that toxin that they were dealing with. So as people are getting vaccinations now, increasing their secretory IgA helps the vaccination to be more effective. Supplementation with Bacillus subtilis stimulated systemic immune response in seniors by significantly increasing interferon gamma in the probiotic group. Bacillus subtilis significantly reduced the frequency of respiratory infections. Obesity is associated with altered IgA recognition of the microbiota. Despite having normal IgA levels in their serum, children with obesity have significantly lower salivary secretory IgA, suggesting that impaired targeting of their resident microorganisms may play a role. So when you have obesity, you develop a deficiency of secretory IgA, which then allows more inflammation to occur in your intestines. That's the first responder, secretory IgA. I'm going to talk about a second responder now that most people have not heard that much about, and that is polyreactive antibodies. They're a major component of the natural antibody repertoire and bind to a variety of structurally unrelated molecules. We think of antibodies as being tissue specific, like thyroid antibodies, they attack thyroid, or gluten antibodies attack gluten. Polyreactive antibodies can attack a number of different unrelated tissues or substances. These antibodies are thought to provide a first line of defense against bacterial infections and play a major role in the clearance of apoptotic cells. So when we have a whole new body every 7 years, every cell in your body regenerates. How does that happen? You have to get rid of the old and damaged cells to make room for the new cells. That's why there's a normal reference range for thyroid antibodies or a normal reference range for myelin antibodies. If you're in the normal range, it means you're taking out as many cells as you're making. So it's neutral, normal. But when you have elevated antibodies, you're losing more cells than you're making, right? Polyreactive antibodies help to clear up the old debris of apoptotic cells. They play a major role in getting rid, because you can't make enough muscle antibodies to get rid of all the damaged muscle cells when you exercise, as an example. You can't make enough of those antibodies quickly. So polyreactive antibodies get rid of some of the damaged muscle cells and thyroid cells and brain cells and joint cells. That's the job of polyreactive antibodies. They bind to a variety of structurally unrelated antigens. They're a major contributor to the broad antibacterial activity of the natural antibody repertoire. These are really the good guys. We want these. Monoreactive antibodies means antibodies to your thyroid. They just go after thyroid. They don't do anything else. That's a monoreactive. Polyreactive antibodies go after many different things. So on the right side, you see the affinity, which means how directly are they associated with one tissue. And the monoreactive antibodies have high affinity. Thyroid antibodies go after thyroid. But polyreactive antibodies can go after thyroid, myelin, cerebellum, collagen, doesn't matter. They're polyreactive. They can attach themselves to old and dying cells throughout your body. The ability of polyreactive antibodies to bind to a variety of different antigens suggests these antibodies represent the humoral component of the innate immune system. Have you ever heard of the humoral component of the innate immune system before? We think there's two different immune systems. There is the innate immune system and the humoral or the adaptive immune system. Well, now we've got somebody in between. We've got the humoral component of the innate immune system, meaning they're there as first responders, like the innate immune system is a first responding system. In fact, upon entering the host, pathogens will be exposed almost immediately to polyreactive antibodies, since these antibodies are constantly present in the serum. So you've got secretory IgA in the oral cavity and in the bloodstream. You've got polyreactive antibodies. If any of these threats, these bugs, get into the bloodstream, if secretory IgA can't handle it, and the other cytokine storm that's produced in your gut to kill invaders can't handle it, and some of the invaders get into the bloodstream, almost immediately in the bloodstream, these polyreactive antibodies will bind onto them and escort them out. The initial encounter of polyreactive antibodies with pathogens could serve as a first line of defense and give the adaptive immune system time to be activated. So if you get a Klebsiella infection and Klebsiella gets into your bloodstream, it takes a few days before you make enough Klebsiella antibodies to address it. So during that time, it's the polyreactive antibodies that are first assigned to go after and grab Klebsiella. See if you can get rid of this right away. So they are first responders in the bloodstream. And to show you how effective they are at binding to different bacteria, they compared the monoreactive antibodies, meaning the antibody for strep, and the antibody for Streptococcus oralis, J22, that's in the oral cavity. The antibody for that grabbed about 4.6% of the strep. But polyreactive antibodies grab 75% of the strep. And just look down the line and you can see the numbers are jaw-dropping as to how effective polyreactive antibodies are compared to monoreactive antibodies. They're our friends. Now, stimulation of toll-like receptor 4 results in a 40-fold increase in polyreactive antibodies, because toll-like receptor 4, if you remember from our talk on gluten, on the second webinar, we talk about gluten activates toll-like receptor 4 in all humans. And what we see here is that if toll-like receptor 4 is stimulated, because that's the sentry standing guard to protect us from any bugs that come out of the stomach into the proximal part of the small intestine. If toll-like receptor 4 gets activated, there's a 40-fold increase in polyreactive antibodies. To get ready, because there's a bug that's trying to get in right now. Okay, so that's polyreactive antibodies. And how do you increase polyreactive antibodies? Somewhere around 50% of IgM antibodies are polyreactive, somewhere around 50%. How do you increase these antibodies? You have to have an immune system that is calmed down. You can't have a hypersensitive immune system, meaning it's fighting constantly for you, constantly on overdrive, an overexpression. Remember, it's not an exaggeration, it's an overexpression. When you have an inflammatory disease going on, you have an overexpression, and your immune system is working hard and it's working overtime. You want to increase polyreactive antibodies by calming down the immune system. How do you do that? Reducing the triggers of inflammation, which we talk about in webinar number 2, webinar number 3 about intestinal permeability, and webinar number 4 about the development of autoimmune diseases. We talk about the environmental triggers. There are so many, from the air and air pollution, the foods, the pathogenic bacteria in your gut. The harder your immune system is working, the easier it is to deplete your body of polyreactive antibodies. Okay, the next topic I want to talk about is because of the current times we're in, and there's a new condition that's developed called long haul COVID. And they looked at 1,959,000 COVID-19 patients for the prevalence of post-COVID conditions 30 days or more after they received their diagnosis. So how many of these people healed completely? How many didn't? And what did they find? Of patients who were hospitalized with COVID-19, a post-COVID condition was present in 50% of them. Of patients who were symptomatic but not hospitalized, it was 27.5%. And of patients who were asymptomatic but tested positive, 19% of them now have symptoms. So this is a serious concern here in Costa Rica and throughout the world of the post-COVID syndrome. It's being called long haul COVID. Of the 4 mental health conditions evaluated as post-COVID conditions, anxiety was the highest, and that makes a lot of sense because of all of the news reports and the terrible news coverage for this event that's going on in our lives right now. There's so much exaggeration on the news, it's embarrassing. So it's understanding that anxiety is very prevalent right now. Depression was second, adjustment disorders were third, and tic disorders were fourth. And in this article that came out in the Journal of the American Medical Association, they talk about individuals experiencing persistent symptoms and a decline in their health-related quality of life. And what did they tell us there? They looked at laboratory-confirmed severe acute respiratory syndrome, SARS-CoV-2 infections, and 6.2% of these people, they were fine. They didn't have any symptoms. 85% of them had complaints, and 9% had moderate or severe disease. This is 6 months after being discharged from the hospital. 85% of people. So any of your patients who have been hospitalized with COVID and they're back home now, and they're grateful to be home, 85% of them still have inflammatory conditions going on. Hypertension was the most common comorbidity, and the survey was completed a median of 169 days after they were ill. So they're suffering long-term with these conditions. Fatigue was very common. Loss of sense of smell or taste was very common. And these are the conditions that were the primary conditions and the percentage of people. So the percentages are on the left. You see 20, 40, 60. The dark bar is a mild illness. The light blue is a severe illness. The orange color is mild illness. And, excuse me, the dark bar is mild illness with acute COVID. The dark orange is mild illness post-COVID. The light blue is severe illness, acute COVID, and the light orange is severe illness post-COVID. And you can see that there is a substantial number of people that are suffering long-term with these symptoms: muscle body aches, difficulty with breathing, coughs, runny nose, diarrhea, ear pain, sweats, rash, chills or shivering, feeling feverish. Looking at 1,900,000 people, there's hundreds of thousands that are still suffering. And we need to be aware of this for our patients. And I just wanted to give you a reminder, this came out from the first webinar we did about vitamin D, but why it's so crucial right now. And every patient should be checked for their vitamin D level, every single patient. It's such an inexpensive test. It's even available as a finger prick test, really easy to do, but it's crucial. And I'm going to show you a couple of reasons why. First, this is a drawing and a picture of the intestines and the tight junctions between two mucosal cells in the intestines. And you see in the upper part here in box A, this is the artist's drawing of two epithelial cells. And in between is the tight junction here. Box B is a photo of a tight junction. This is the microvilli here. Box C, they enlarged the photo, and you can see there's loops here. I call it the Panama Canal. And over on this inside the box here, the artist's drawing of the Panama Canal. You see these kissing joints here where the two sides of the cells touch each other, and that it's these proteins that form the tight junction strand. And when you expand the tight junction strand, the artist's drawing shows us here is the space between the two cells, and the proteins are like shoelaces holding the cells together. And then when zonulin gets secreted, it's like you've untied the shoelaces so the shoes are looser. The cells can open up a little bit, and these gates of the Panama Canal open and close. And here is another picture of a tight junction. This is the microvilli going up here. I love pictures. They really help us to see and understand. These are the microvilli here. And I'm going to show you the enlargement here. This is what I wanted to show you, was the enlargement of the tight junction strands at the kissing joints. Because what happens, food comes in, this gate opens to the Panama Canal, the food comes in, the immune system checks it out. This gate closes, the bottom gate opens, the food goes down a little bit further, now the top gate above the food closes, the immune system checks it out. The bottom gate opens, the food goes down further, now the top gate closes, the immune system checks it out. And this happens between every epithelial cell on the lining of your intestines. Now, why am I showing you this? Because vitamin D plays a critical role in mucosal barrier homeostasis in the gut by preserving the integrity of the tight junction complexes and the healing capacity of the colonic epithelium. Vitamin D markedly enhances tight junctions by increasing junction protein function at the kissing joints and the structural integrity of the tight junctions. Vitamin D controls the gates of the Panama Canal in your gut. And when you have a insufficiency of vitamin D, you get leaky gut. And that is the gateway into the development of the systemic inflammation that people suffer from that causes chronic inflammatory diseases. So for all of your patients who have tested positive for SARS-CoV-2, you want to make sure you're checking their vitamin D and that their vitamin D levels are accurate for them. So all of these different areas are modulated by vitamin D. That's why I'm showing you these pictures of the anatomy so that you can visualize the role that vitamin D plays. It controls the gates of the Panama Canal. The role of vitamin D in reducing risk of the common cold grouped these mechanisms in three categories: physical barrier, cellular natural immunity, and adaptive immunity. Vitamin D maintains tight junctions, gap junctions, adherence junctions in the intestinal epithelium and also the lung epithelium. Vitamin D enhances cellular natural immunity in part by reducing the cytokine storm induced by the innate immune system. I talk about it in much more detail in webinar number 1 when we talked about the current virus and what to do about it. To reduce the risk of infection, it's recommended that people at risk of influenza or COVID-19 consider taking 10,000 units of vitamin D per day for a few weeks to rapidly raise their vitamin D levels, and then maintenance of 5,000 units per day. Vitamin D is known to mitigate the scope of acquired immunity and regenerate the endothelial lining. This may be beneficial in minimizing the alveolar damage caused in acute respiratory distress syndrome. And look at the title of this paper: A Comprehensive Literature Review on the Clinical Presentation and Management of the Pandemic Coronavirus Disease 2019. And they talk about the critical importance of vitamin D. They looked at 11,000 people and showed that there's a 12% overall protective effect of vitamin D supplementation against bacterial and viral acute respiratory tract infection. It's not 100%, but 12% is great. It's going to help, and it may be the difference between life and death for people. These protective effects increase to 19% in those individuals on daily or weekly regimen of vitamin D, because some doctors have been told to give a monthly bolus of vitamin D once a month. It doesn't have the same effectiveness when you do that. There's a 70% protective effect when vitamin D deficiency is corrected, meaning if you check your patients and they're deficient, you give them 70% increased protection against a severe reaction to the pandemic coronavirus disease 2019. And I'm going to show you this last study on vitamin D. They looked at 190,000 patients. This is from a major laboratory in the US called Quest Labs, where they checked, these are all positive patients for SARS-CoV-2. They also checked their vitamin D level. And what did they find? SARS-CoV-2 positivity is strongly and inversely associated with circulating vitamin D levels, a relationship that exists across latitudes, didn't matter where they live, races, ethnicities, sexes, age ranges, didn't matter. If they're low in vitamin D, they're more likely positive for SARS-CoV-2. And this was the graph they had in that study, showing that the higher your vitamin D level, getting closer to 60, the lower the positivity that you've got this virus. And our recommendation is the goal is between 50 and 75 nanograms per milliliter. And here is 60, and down here, and it just keeps low when you have that dosing. For each 1 nanogram per milliliter increase in vitamin D levels, it's associated with a 1.6% decreased risk of contracting this virus infection. This is 190,000 people that they looked at that were positive for SARS-CoV-2, and they checked their vitamin D levels. And this is the last slide I'll show you about vitamin D, because it's such a shocker. 780 patients with SARS-CoV-2. And if their vitamin D was below 19, every one of them died. If their vitamin D level was above 33, none of them died. So the question is, where do you want your vitamin D level and your patient's vitamin D levels? That's the sweet spot where it drops, the risk drops dramatically when you get over 27.5. But our recommendation for optimum levels is between 50 and 75 nanograms. So in rebuilding the microbiome, please go back and watch this webinar that we did, because it's about a 25 minute presentation just on the foods and what nutrition to take to rebuild the microbiome. Once again, all of these studies that I've just referenced are available to you at the dr.com/CR621 for Costa Rica, June 2021. And 19 of them are the full studies, and the others are connections to the abstract. Please take care of yourselves. Tell those important to you how much you love them. And with that, I will say thank you very much for your kind attention. And now it is time for questions.
Hello, thank you, Tom. I was thinking about, because you talk about the problem with the obese people, but I was thinking about these fat, skinny people that we have, these people, they have all this visceral fat in the belly, and also they are very, very dangerous, because it's not that you are overweight. Sometimes your weight is okay, but your fat is too much, so you are going to have a lot of inflammation also.
That is a very important topic. We call them the sleepers. They're the sleepers. They're hiding. You can't see the inflammation so easily in them, but inside their bodies, when they have normal weight, but if they have a high percentage body fat, and if they're carrying a lot of the abdominal concentration of that fat, they're highly inflamed. And you're absolutely right. It's a very dangerous situation. It puts them at high risk.
Yes.
Every one of them has
yes.
intestinal permeability. Every one of them that I've ever checked has intestinal permeability, the gateway in the development of autoimmune diseases.
Yes, and sometimes when we check the protein C-reactive and the homocysteine, they are very high sometimes. So yes. It's a very dangerous situation. And so people need to understand that it's not only overweight, it's the visceral fat that is important.
That's exactly.
There is a question about how can we increase the polyreactive antibodies?
You have to make sure that you're getting adequate, high quality protein, most important. And there are urine amino acid tests now where you can find out. They're not expensive. And it's so common that when people have chronic inflammatory diseases, they're protein deficient. Even if they're eating protein, that they're amino acid deficient. You see it all the time where out of 24 amino acids, 21 of them are very, very low. And you can't build new tissue. You can't build a strong immune system with low protein levels, low access to the raw materials. That's the first thing. The second thing is that you must build a healthy microbiome. The healthy microbiome is the genesis of your antibody production of IgM, which are traditionally known as the first responders. But now we know that polyreactive antibodies, and over 50% of IgM antibodies are polyreactive. So they've been trained to be polyreactive. So you must build the diversity of a healthy microbiome. It's extremely difficult to produce adequate amounts of immunoglobulins when we have dysbiosis. And it's very, very common to see people that have deficiencies of total IgA, total IgG, total IgM. It's very common to see when they are in an inflamed state with a dysbiotic microbiome.
Mm-hmm. And also sometimes because it's very difficult to find these amino acids in the food, because I don't know how to say this, but because sometimes you eat food, but it doesn't have all the nutrients that you need.
That's very true.
So it's hard.
That's very true. There's a difference between farm-raised salmon and wild-caught salmon. There's a difference not only in the fats, but also in the protein structure. There's a difference between grass-fed cattle, beef, and feedlot beef. There's a difference in the composition of the proteins in the meat. So the way an animal was raised or the way chickens are raised determines the quality of the protein of the meats or the eggs that we're eating.
Mm-hmm, mm-hmm. But I think also, because sometimes you show us these studies that in Costa Rica, that we have many, many children with obesity, and sometimes it's people that cannot afford this kind of food because they're expensive. But I think sometimes the problem is that these people is eating some food that is very bad, like a lot of sugar, additives, and sweeteners, and wheat, of course. So I think maybe if we cut that, we can help these people.
I think that's a very good idea. And I often recommend to patients, do not buy any food in a bag, because what comes in bags? Sugar, potato chips, popcorn, just bad carbohydrates. So I say, think before you grab the bag. Is this a good food or not? So it helps sometimes, for people to think like that.
Mm-hmm. And I also always say that this bag has a name that you cannot say it because it's very difficult. So it's not natural. It's like something synthetic in there, no?
Right.
They are asking if there is a time hour where you have to take vitamin D.
Is there a time?
Maybe, yes, in the morning, maybe. I don't know.
No. Usually it's best taken with food because it's a fat-soluble vitamin. So you want some fat-digesting enzymes that helps you to absorb a little bit easier, but it's not essential. There's not that big a difference. I've only seen one study on that, and the reference was okay, but it wasn't that big a difference either way. Personally, I take vitamin D when I remember to take it. And so when I'm walking past the counter, the vitamin D. So I'll grab it, and then I take some water, and I take it now. It's more important to get it in, but for some people, especially if they have difficulty with digesting fats, then you're likely to absorb more of the vitamin D if you take it with food. Now, the exception to that, and on my website, for example, we have micellized vitamin D. Micellized vitamin D is absorbed in your mouth, and it increases your vitamin D levels 5 times higher than emulsified vitamin D. The same dosage, but your blood values go up 5 times higher with micellized vitamin D. And it's not expensive. So I don't know if it's available in Costa Rica, but it may be. That's micellized, MyCellized.
No, it's not available. But, and also is the problem is that it's not coming with the K2 sometimes. The majority of time is not with K2.
Right, right.
Yes.
K2 is important and vitamin D is essential. So
yes,
if all you have is vitamin D without K2, take the vitamin D.
Yes.
If you have an option with K2, great, that's better.
Mm-hmm. Yes, of course. So we don't have more questions, Tom. So thank you, Tom. Thank you for your time. And I hope that we can talk more about this topic or others in the next future. Thank you.
Thank you very much. It's a real pleasure. Thank you.
Y gracias a todos, de verdad.